Hello, hearty welcome to you. We will look into how to find out maximum and minimum values of a trigonometric expression or a expression something like a cos theta plus b sin theta plus c. So before we start ahead, we just want to recap that we know that sin theta values lie between -1 and 1. Same case is also with cos theta. So we will leverage this. We'll leverage this to find out the maximum and minimum values of trigonometric expression a cos theta plus b sin theta plus c. Now, we know that sin theta values are between -1 and 1. Here I have a and I have b. If somehow I can convert this first term, I can convert the coefficient of a cos theta and b sin theta, that is a and b, into a trigonometric angle, or I can convert them into a single sine or cosine expression. Then it will be easy to find out the maximum minimum values by using the inequality which says that sin theta or cos theta value should be between -1 and 1. So let's start with that. What I will do for that, first thing what I will do is, now I see that the coefficients are a and b. So what I will do is, I will draw a right angle triangle to find out a angle which will have sine and cos with the values of a by something. So let us say that value is alpha. We know that I should have here, suppose I want to make this as sin theta, I am looking at the form of sin alpha cos theta plus cos alpha sin theta. I hope you are comfortable with that. So our idea is to convert a cos theta plus b sin theta plus c into the form of sin alpha cos theta plus cos alpha sin theta. Now I have an angle alpha and we have in sin A, so I'll write it as A here, and you know also for cos I have B, so you know that if I have A and B as two sides, the hypotenuse will be nothing but equal to square root of A square plus B square. So what we have done is very simple. We have A cos theta plus B sin theta plus C, for which we have to find out the maximum and minimum values. Now what we are trying to do now is convert this A cos theta plus B sin theta into a single sine expression by using compound angle formulas, either sine of theta plus alpha or cos of theta minus alpha, cos of theta plus alpha. Leveraging that property, we want to convert this into a sine, then we want to use the inequality whatever we have. Okay, now we know from here sin alpha equal to a by square root of a square plus b square. So I can write it as sin alpha only when I have a by square root of a square plus b square. So I will write it as a by square root of a square plus b square into cos theta plus b by square root of a square plus b square into sin theta plus c. But we are dividing by square root of a square plus b square. We should multiply, otherwise it will not be equal to our earlier expression. Now this is perfectly fine. Okay. Now mostly generally we call this as equal to r, and we will say a equal to r sin alpha and b equal to r cos alpha. You can see that cos alpha equal to b by r, so b equal to r cos alpha. Okay, now I can convert this as nothing but r into a by square root of a square plus b square is nothing but equal to sin alpha cos theta plus cos alpha sin theta. And we have the constant term, that's nothing but equal to c. Even we don't have also, it's okay, fine. Now this is nothing but of the form sin a cos b plus cos a sin b. You can see that very clearly. And what I can write it as? I can write it as sin of a plus b. I can write this whole thing as sin of a plus b. So my next step will be r into sin of alpha plus theta plus c is the expression for which we have to find out the maximum and minimum values. What we have done? We have leveraged the properties. We have used the compound angle. We want to convert this into a single expression. So for that we have taken a and b. We found an angle such that sin alpha equal to a by r, or a by square root of a square plus b square, and cos alpha equal to b by square root of a square plus b square. Okay, right. Now let's come back. We know that minus 1 is less than or equal to sin of alpha plus theta less than or equal to 1. We know that very clearly, because sin of any angle, it should be between minus 1 and 1. Now what I have to find out the value is nothing but I have r here. So I'll multiply with r. It becomes minus r is less than or equal to r sin of alpha plus theta less than or equal to r. And in addition, I have a constant term. So it becomes now c minus r less than or equal to r sin alpha plus theta plus c less than or equal to c plus r. So that gives me the maximum and minimum values are maximum value and minimum value of any trigonometric expression of the form a cos theta plus b sin theta plus c is nothing but equal to maximum value is c plus square root of a square plus b square. Minimum value is c minus of square root of a square plus b square. So that's how we can find out the value of a trigonometric expression. We'll do some simple example. Before that, let me just try to summarize. We have a trigonometric expression of the form a cos theta plus b sin theta plus c. We want to find out the maximum and minimum value of this particular trigonometric expression. Now what I want to do is, I want to leverage the compound angles or compound angle formula, where you say sin a cos b plus cos a sin b equal to sin of a plus b, so that I can leverage the trigonometric inequality of sin theta, which says that sin theta value should be between minus 1 and 1. Now to convert in the form of sin alpha cos theta plus cos alpha sin theta, I have to find out an angle alpha in such a way that sin alpha is equal to a by r and cos alpha equal to b by r. So I have restructured whatever I have in such a way that I have divided by square root of a square plus b square, and I have also multiplied so that its value is not modified. Now that's nothing but r into sin alpha cos theta plus cos alpha sin theta, which I can write it as sin of alpha plus theta. Now once we have converted that, we went back to our trigonometric inequality of sin, which says that any angle of sine, that sine function or its value should be between minus 1 to 1. So the range of sine lies between minus 1 and 1. Now what we want to find out is r into some sine plus c. We know sine is between 1 and 1. Multiply with r, it will be between minus r and r. You add c, it will be between c minus r and c plus r. So simply, if you have a cos theta plus b sin theta plus c, its max value is c plus square root of a square plus b square, and min value is c minus of square root of a square plus b square. Now let's leverage this and try to do some simple examples. So we have a simple trigonometric expression here, 12 cos theta plus 5 sin theta plus 4, which is in the form of a cos theta plus b sin theta plus c. So a is 12, b is 5, c is 4. We know the formula straightforward, we can go and apply it. Max value is nothing but equal to c plus of square root of a square plus b square, and min value is nothing but equal to c minus of square root of a square plus b square. If you want, you can explain in detail whatever we have done in the last screen. You can explain that in detail how you got this value when you are solving this problem too. Now what is c? 4 plus square root of 12 square plus 5 square, and minimum value is 4 minus of square root of 12 square plus 5 square. This is 4 plus 13, and this is equal to 4 minus 13. The minimum value is minus 9, and the positive value is nothing but 17. So the maximum and minimum value of this expression lies between minus 9. Maximum value, the values of this expression lies between minus 9 and 17. The minimum value is minus 9 and the maximum value is 17. Let's do one more. Okay, here you go. Let us take one more simple example. Let us say we have 5 cos theta plus 3 sin of pi by 6 minus theta plus 4. This is what we have. Now it's not straightforward because we don't have it in the form of a cos theta plus b sin theta. I don't have pi by 6, I don't have theta. Instead of that I have pi by 6 minus theta. So I will apply the formula of sin of a minus b and try to expand this. So let's go to the next step. That will be 5 cos theta plus 3 into sin pi by 6 cos theta minus cos pi by 6 sin theta plus 4. That's nothing but equal to 5 cos theta plus 3 into sin 30 is 1 by 2 into cos theta minus cos pi by 6 is root 3 by 2 into sin theta plus 4. If you simplify that, we have 5 plus 3 by 2, that is nothing but equal to 13 by 2 cos theta minus 3 root 3 by 2 sin theta plus 4. Now we have it in the form of a cos theta plus b sin theta plus c. So a is 13 by 2, b is 3 root 3 by 2, and c is equal to 4. So I can directly go to the formula and I can substitute it. I can say max value is equal to c4 plus square root of 13 by 2 whole square plus minus 3 root 3 by 2 whole square. That's nothing but equal to 4 plus square root of 169 by 4 plus 27 by 4. That's nothing but equal to 4 plus square root of 196 by 4 is 49. That's nothing but equal to 11. So the max value is nothing but equal to 11. Let's look at the min value. What will be the minimum value? The minimum value will be nothing but min value is equal to 4 minus of whatever you have. That's nothing but 4 minus 7. That's equal to minus 3. So the minimum value is minus 3 and the maximum value is 11. This is pretty straightforward and simple. Now let's look at some problems where it may not be straightforward. We have to do a little bit of work on them. Let's look at this one. This is very interesting problem. Now we have seen only a cos theta, b sin theta, but I have here cos square and sin square, sin x, cos x. Please remember, whatever is given to you, you have to convert that in the form of a cos theta plus b sin theta. so that you can apply the formula. So let us see now how we have to proceed with this. Now you can see, first of all, if I can see here, this is crucial, 6 sin x cos x, and if I want to make it as a cos theta plus b sin theta or whole square of it, because I see that there is cos square and sin square, so I am looking at something like a cos theta plus b sin theta whole square now. This seems to be my 2ab term because I have both sin and cos here. And how a and b will be, that defines how we have to proceed. Now suppose I take b equal to 3 sin x and I take a equal to cos x. I cannot take it because b square should be 9 sin square x. I have only 3 sin square x. So since I have only, if I take 1 sin square x and 4 sin square x, between 1 and 2 I have only 1, so I will take it as 2 into sin x. This is my b, and I have a is nothing but equal to 3 cos x. Once we are clear with this, how we have gone through this, remaining everything becomes simple. Now this term is, if this term is 2ab term, what will be my b square and what will be my a square? Let's look into that. Now a is, okay, I think I have swapped them. This is b and this is a. So a will be 3 cos x. So it becomes 9 cos square x plus b is sin x. So I will have sin square x. But I have something left out. 6 sin x cos x is matching, 5 is matching, 9 cos square x, still I have to add something more. What is that I have to add? 2 cos square x left out here, and here I have a difference of 2 sin square x. So I will add it as 2 sin square x. Nothing but what we have done, we have restructured whatever is given to us in such a way that we can convert it in the form of a cos theta plus b sin theta or to the power of 2 or 3, whatever it is. Now this is nothing but equal to a plus b whole square, that is nothing but 3 cos x plus sin x whole square plus, you know that 2 cos square x plus 2 sin square x is equal to 2. So I can write it as 7. Now you can see very comfortably we are back to our a cos theta plus b sin theta plus c form. Okay. Now I have here 3 cos x plus sin x whole square. First let me find out what are the minimum and maximum values of 3 cos x and sin x. I'll do it here. 3 cos x and sin x, this is what I have to find out the maximum and minimum value. Now a is 3, b is 1, c is 0. So my values will be minus of square root of a square plus b square and plus square root of a square plus b square, because c is 0. And that is nothing but minus of 1 plus minus of 9, should I say 3 square plus 1 square, and plus 3 square plus 1 square, that is minus root 10 and plus root 10. So minimum is minus root 10 and max value is plus root 10. Now let's come back here. We have to find out the maximum value of this expression, what is given to us as 11 cos square x plus 3 sin square x plus 6 sin x cos x plus 5, which we restructured as 3 cos x plus sin x whole square plus 7. Okay, right. Now we know the maximum value of 3 cos x plus sin x is root 10. So if I square it, the max value of this expression will be happen only when 3 cos x plus sin x is having maximum value. The maximum value it has is root 10. So the max value of the expression will be root 10 whole square plus 7. That's nothing but 10 plus 7 equal to 17. Now let's look at what will be the minimum value. If you see here, either you have minimum value also, when you are squaring them, the value will become same as max value, right? If I have minus root 10, if I square it, it will become 10. That means this expression is not having the minimum value. The minimum value of this expression happens only when it is 0. Can you tell me why? Because even you take a positive value or a negative value, when you square them, you are becoming again positive. That means you are adding to 7. But what we want is the minimum value. 7 you cannot do anything, but I should have this as 0 so that I can say minimum value is 7. Other than that, remaining all values will be more than 7. So the minimum value is nothing but 0 plus 7 equal to 7. So that's a good example. And we will wrap it up with another simple example. Here we go. The last example. This is the last example we have. 12 sin x minus 9 sin square x. If you remember, in the last problem, whenever we have seen a square or b square, we took this term as 2ab term. So let us continue that. We will use completing the squares algebraic method so that we can convert this into a plus b whole square form and adding or subtracting something from it. So what it will look like? 12 sin x minus 9 square x. So can I say this is 3 sin x whole square? That means a equal to 3 sin x. Then what will be 2ab term? 2 into a something. A is nothing but 3 sin x, that is 6 sin x, into 2. That means my b is nothing but equal to 2 and a equal to 3 sin x. Now I have 2ab and I have minus b square. But what form I want to have? I want to have either a square minus 2ab plus b square, or I want to have a square plus 2ab minus b square, or any one of these multiplied by minus. So what I should have now is, what I will do, I will take a negative of this and I will say this is nothing but equal to 3 sin x whole square minus 2 into 3 sin x. Now this is nothing but a square minus 2ab. I am missing b square term. What is b? B value is 2. So it should be 4. Now remember that minus 4 is in minus, so you have to add another 4 to it, or simply it will become 4 minus of 3 sin x minus 2 whole square. You can cross check that. 3 sin x is 9 sin square x minus 9 sin square x. 2ab term is 12 sin x, minus of minus is plus. B square is plus 4, minus 4 plus 4 cancels out. Now this is the expression for which you have to find out the max and minimum values. Now what will be the maximum value? The maximum value of this expression occurs only when this value becomes 0. As I said earlier, if you take any other positive or negative value, you will be subtracting more value from 4. That means it will not be the maximum value. So 3 sin x minus 2 should be equal to 0 to have the max value, and the max value is nothing but equal to 4. Now when it occurs when sin x equal to 2 by 3. So that's how you can find out the maximum value of this particular function 12 sin x minus 9 sin square x. You can do it by differentiation also. That we will see when we are going through differentiation. That's simply a, a simple and brief explanation on maximum and minimum values of a cos theta plus b sin theta plus c, with some examples to understand and apply those concepts. Thanks for visiting. Bye for now. See you in the next session.